Hello and welcome to another video demonstration courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Norton. Well, today's conversation, or at least with today's video, we're going to be talking about the conservation of angular momentum. So a lot of you might remember that we talked about linear momentum and that we had to look at before an instance occurred has to equal the total momentum after the instant occurred, typically with, let's say, a collision. Well, now with angular momentum, we're saying, well, if I'm rotating, the angular momentum when I start has to equal the angular momentum I finish. So kind of similarly to if I was to start spinning on the stool, and we go around, all of a sudden I bring my arms out, I slow down, I bring them in, I go fast. Well, that's one way of looking at angular momentum. But the angular momentum definition is capital L. That the angular momentum before has to equal the angular momentum after. And the angular momentum is defined as the moment of inertia of an object times the angular velocity or the angular frequency. So we're going to do a demonstration where, what if I had a bicycle wheel and I was spinning it? Well, if I'm spinning this bicycle wheel, depending on which orientation, the angular velocity vector will be pointing out of the plane of the rotation because it's the change of angle with respect to time. So if I was sitting on this stool and I was pointing the angular velocity vector upwards, then all of a sudden I rotated this wheel. And if I'm not adding any extra friction on the ground, I'm not moving, I should move. Which is kind of a really interesting and cool thing to do, is just going, I'm just going to move a tire, it's already spinning, and it's going to move me. So let's see if I can get this rotating stool to spin in both directions. So, this is a little bit difficult because A, I have to hold this out perfectly horizontal, and I have to spin it. I have to get enough speed, that way you can see it move. And then I've got to try to rotate it. So let's see if I can do this adequately. I'm stopped, and now I move. Stopped, and now I move, all from spinning the tire. So I'm spinning this tire, and I'm moving this way to cancel out the angular velocity vector that's pointing that way. So now if I was to spin it on the other side, I should get the same thing in the other direction. But only I should spin in the opposite direction now. Spinning, I stopped. Now move a little bit again to my left. Stopped, move to my right. Stopped, move to my right. And I stopped. So, kind of cool that I can have a spinning bicycle move me when I'm not trying to move anything else. Well, thank you for that, paying attention to this video demonstration, and have a wonderful day.